Right? We're getting closer and closer to get that distinction. All right, and so today what we'll be doing is looking at 2014 paper. All right, and I have a strong feeling that I don't know, I just have a strong feeling that majority of the questions are going to be repeated from the range of between 2013 to 2015. I just have a strong feeling. Because as you know, over every 5-year period, what they do is they make new questions and they rotate these questions for a 5-year period of time. But I just have a strong feeling that after the 2015 to 2019 batch, that they're going to go back to a lot of the questions from 2013 to 2015, in particular, that range. All right, so let's start. So question 1 in the 2014 paper, here we have a complex number, 2 minus I over 3 plus 2I. All right, so that easy question. All you have to do is rationalize the denominator. So if we multiply this complex number by the conjugate of the denominator. So that's all for this question. So let's do that. So we have some complex number z, and z is equal to, that question is 2 minus I over 3 plus 2I. 2 minus I over 3 plus 2I. And so multiply by the conjugate of the denominator, which is 3 minus 2I. So multiply by the conjugate of the denominator. And so first let's multiply at the numerator. We have 2 times 3, that's going to be 6. They will multiply 2 times minus 2I to get minus 4I. We multiply minus I times 3 to get minus 3I. They will multiply I minus I times minus 2I to get positive 2I squared. Then in the denominator becomes the difference of 2 squared, which is just 3 squared minus 2I squared. So simplify it, and what we're going to end up getting is, we know that I squared is minus 1. I squared is minus 1. And so what we end up having right here is I squared minus 1 times 2 is minus 2. 6 minus 2 is 4. And then we have that minus 4I minus 3I is minus 7I. So we have 4 minus 7I being divided by 3 squared is 9. And then minus 2I all square is 4I squared. But I squared is minus 1, so it becomes positive 4 times minus 1, which is plus 4. Plus 4 plus 9 is 13. We didn't have to take so long, as we know. Doing a test, bam, we're done that long time. All right, but just for the fun of it, right, because I know we'll be finishing the exam in 30 minutes. You can go back over the whole paper and doing it slow and just talking it to yourself. How nice it was. So that's question 1, which is A. That's question 1. Question 2. It says, which of the following is a sketch of the locus of the point represented by the complex number given that z plus 5i is equal to 3. The modulus of z plus 5i is equal to 3. All right. So the first thing is that in order to talk about the locus, you have to write it in its standard form. So whenever you're given the modulus of z plus 5i, we want to write it in a form, the modulus of z minus a is equal to r. And so what we're going to do is rewrite this as the modulus of z minus, in bracket, as a complex number. This is 0 plus, well, 0 minus 5i. And that's equal to 3. So now we end up getting the center. From this piece, we get the center. And the center is 0, -5, and the radius is 3. So we're looking for a circle with center 0, -5, and a radius of 3. So that's what we're looking for. So 0, x is 0, and y is -5. Now this is the option D. So all of them looks to be the same thing, but what we have to focus on is the x and the y coordinate. In the first one right here, it's telling us x is -5 and the y coordinate is 0, so that's a no-no. And so that's why D is the answer, because we need the center to be 0, -5. All right, so as usual, the first part of the paper, very easy. All right, now this question we're being asked for to find the integral of tan cube x. First and foremost, they told us that in represents the integral of tan to the n of x dx. And so to get tan cube, all we have to do is replace n with 3. So to replace n with 3, in is equal to, they tell us in is also this formula. So put in n as 3 right here, and we get tan 3 minus 1 of x. 3 minus 1 is 3 minus 1 is 2 over 3 minus 1 is 2. So we get tan squared over 2 minus, we'll put 3 right here for n again, and then we get 3 minus 2 is just I. And so now I, meaning when n is 1, will just be tan x. So looking for tan square x over 2 minus tan x. That is D. Easy question, nothing there to do.
Afternoon, sir.
Afternoon.
I'm on the road right now, you know.
Okay, all right, just will you be home? Are you on your way home?
No, not as yet, sir.
Okay, I'll send you the video recording of the session.
Yes, sir.
All right. Also, if there's any issue, as I say, we're approaching close to exam. If there are any issues, you have any past paper from maybe specimen, I don't know, some persons like to practice from 2005, some like to do specimens. You have other multiple choice of practicing. Feel free to send them to me through email or whatever the problems you may have. All right,
Okay, sir.
as we boil into working to try to get that distinction.
Wait, so I can still look at some of the questions that you're doing, you know.
Okay. All right, question 4. Question 4 now is a partial fraction question. So we need to separate this as a partial fraction. All right. So there are different types of partial fraction. So we have partial fraction when all the terms in the denominator are linear. And then we have partial fraction where the terms in the denominator are linear and repeated.
Repeat that, sir.
Yeah, I wasn't hearing my thought process properly. All right, so what I was saying was that we have linear and repeated, we have just linear, then we have non-linear and non-linear repeated. How do you know when the quadratic factor or the cubic factor is non-linear is when it cannot be factorized? How do you know when it cannot be factorized is by finding the discriminant of the quadratic part. So if you were to find the discriminant of this, you're going to realize that it's going to be negative. When the discriminant is negative, that means this quadratic factor cannot be factorized. So let's look at it now. So right here, x squared plus 6x plus 17. It cannot be factorized, right? Let's say you're trying to factorize this. Right, first you have to do is check the discriminant. The discriminant is equal to b squared minus 4ac. That's the discriminant. Now b is your coefficient of your x term, which is 6 squared minus 4 times a is the coefficient of your x squared term, and c is your coefficient of the constant, which is 17. Now 6 squared minus 4 times 17 is 36 minus, that's 36 minus 68. 36 minus 68 is going to be equal to whatever the number is going to be. It's going to be less than 0. And so what this is telling us is that it has a complex solution, right? So if you were to solve this, this is giving you a complex solution. So since there is no real term that we can get if you were to solve this, then therefore this cannot be simplified. This expression cannot be simplified. It cannot be simplified as linear factors. We cannot simplify it. Cannot simplify. Since it cannot be simplified now, then therefore what this pretty much means is that x times, so I'm just going to call up top r. I don't know, there was some number in the top of the numerator. I think it was x plus 5.
So you have x, q, r, and p. That what I mean?
Oh no, I was saying in the numerator, I think it was x plus 5 for the question. X plus 5?
Yes, sir, x plus 5.
Yeah, x plus 5. So what we're saying we have x squared plus 6x plus 17. This cannot be factorized or simplified. And so what we'd have to do is just write this as, separating this as a partial fraction, we'd have to say a over x plus something over this whole quadratic part, x squared plus 6x plus 17. Now the term that goes above this has to be a term that the power is only, the power difference between the x squared term and the term in the numerator, difference must be 1. And so for the difference must be 1, then it has to be an x term. I can call it dx. Then put a plus c. So notice that the power difference right here, this is really ax to the 0, this is x to the 1. So the power difference is 1. The power difference for this is 1. So when you're separating partial fraction, the power difference is always going to be 1. All right? And that's for when it is a quadratic that we cannot factorize. So we're looking for something of this form. That's the solution. So the only option right there is going to be C. All right, easy question. All right, question 5. Question 5 is asking us to find the value of cosine pi over 2 plus I sine pi over 2 all squared. To do this question, we're going to have to apply the marvelous theorem. So we're going to have to apply the marvelous theorem. So just to remember the marvelous theorem, it states that cosine n theta plus I sine n theta is equal to cosine theta plus I sine theta to the n. That's the marvelous theorem. So that question is the marvelous theorem. So cosine theta plus I sine theta raised to the nth power is equal to cosine n theta plus I sine n theta. That's the marvelous theorem. And so in this question now, it is asking us where theta is. I believe theta is pi by 2. So right here it says cosine pi by 2 plus I sine pi by 2 all squared. And so the n is 2 in this case. So we can replace this with 2. Replace n with 2. And replace theta with pi by 2. So that's all we have to do. Replace theta with pi by 2. Replace theta with pi by 2. And so now it becomes cosine n theta, which is 2 times pi by 2. 2 times pi by 2 is 2 times pi by 2 is pi. And so now the cosine of pi is pi, and so the answer is just -1. So -1 is the answer for that question. They love to put this question, all right, but sometimes what you see they do is the same question. Oh, sorry, -1. A lot of time they put this question, but only difference they do, sometimes you see them put 4, and then another time they put pi, cosine pi by 4 plus I sine pi by 4 raised to the 4th power. It's still going to be -1. And another time I see they put cosine pi by 8 plus I sine pi by 8 raised to the 8. That's just going to be -1. So the trick is, if you see something like pi over 3 and it's raised to the 3rd power, just know the answer is going to be -1. All right, so they love to put this same question, but just change the number right here. Put 3, and so 3 here, or 4, and 4 here. But it's the same question they always ask. The same question. Question 6. It says that z bar or bar z, some people would say the bar come before the z. And so let's read it as bar z. Bar z is the conjugate of z. Which of the following are true? That means the length of the complex number z should be equal to the length of the complex number conjugate Okay, good day, Kyra. Number 1 is A, and number 2 is D. So A for number 1 and D for number 2. All right.
Thank you, sir.
All right, no problem. Back to question 6. So we want to find out which of the following is true about complex number and its conjugate. So first and foremost, if you have a complex number, z, which is equal to a plus bi, or if you want to say x plus yi, whatever the case may be, then your complex number conjugate, z star, well, they call it z bar, but I'm calling it z star, u star because we're all stars, right? So u stars. So z star is going to be a minus bi, And so this will tell us then that the modulus of the complex number z would be equal to a squared plus b squared all square rooted. That's the length of the complex number z. Now the length of the complex conjugate now is going to be the exact same thing, because it's going to be a squared plus minus b squared, but minus b all square is just the same as b squared. It's going to be a squared plus minus b all square. And so they're the exact same thing. They work out to be the same. Since they work out to be the same, so these two are equal. These two are equal, and so therefore the first one is equal I. So we've just proven that z is going to be equal to z star. You can even use actual numbers. So you can call this 5 plus 3i and 5 minus 3i. All right? So you can use actual numbers. So prove the first one, that was I. So no, I is true. So let's check the second one now. There are two ways to check it. First and foremost, I can use a diagrammatic approach where you can say, all right, this is my complex number z. So this is my complex number z. That's your complex number z. That's a plus bi. Now your complex number z star is going to be a minus bi. A minus bi would mean, sorry, let's get rid of that. So this is A and this is B. So now what would be the argument of Z? The argument of Z is always the angle the complex number makes with the positive x-axis. So this is the argument of Z. So let's call it theta. All right, so that's the argument of Z. All right, so Z is this right here. The real part is A, imaginary part is B. Now we need, when you have A and minus B, A and minus B is down here. So this is B, it's minus B. The angle with the positive x-axis right here is going to be different. So this is it now. The angle with the positive x-axis is this now for the complex conjugate. And so therefore, it's not going to be true. So let's call it phi. Let's call the angle right here phi. In this case, theta is not going to be equal to phi because they're in different quadrants. Theta is not equal to phi. And so therefore, the argument of z is not equal to the argument of z bar. That's one way to prove it. But that's a little bit monotonous, or some people would say boring. So another way to prove it is you could use an actual example. For example, you could just say, let z be equal to maybe 1 plus I. Use a simple example. And so the argument of z would just be tan inverse of 1 over 1. And so the argument of z in this case would be pi by 4. Then if you were to now write down z bar, you get that z star is equal to 1 minus I. And so the argument of z would be equal to minus 1 over 1, which would be minus pi by 4. And this would show that they're not equal to, they're not the same. And so that cross out 2. So 2 is out. So 2 is out. 2 is out. That's out. So this one is not true. So cross out that, that's not true. So since 2 is out, we automatically know A is out. and C is out. And then I has to be true. And so therefore B is the answer. So look how you didn't even need to check the next two. The reason being is that I has to be an answer. And so the answer has to be between A or B. But then A has in 2 in it, and we just proved that 2 is not true. And so therefore the answer is B. So we didn't even need to prove the next two parts. Easy does it. Soft with a capital T. So now this question, it gives us an exponential function e to the x plus y minus x is equal to 0. And they want dy by dx. So let's look at that. We have e to the x plus y minus x is equal to 0. That's what we have. And so in order to find dy by dx, we need to differentiate both sides with respect to x. So we differentiate both sides with respect to x. Now, this part right here, you can always break it up as, since the bases are the same, right, you can write it as e to the x times e to the y. That's how you can write e to the x plus y. Since the bases are the same, we add the powers. So we use laws of indices to break it this way. Now, writing it this way makes it easier for us to differentiate to write. Keep the first, then we differentiate the second. Or some people would write VDU plus UDV. It's the same procedure. So let's differentiate it using VDU plus UDV. So this is your V, or this is your U and this is your V. And so you're right, VDU plus UDV. Then differentiate that x part, now we get minus 1, and that's equal to 0. So just need to make dy by dx be the subject now. And so what we're going to get now is dy by dx is going to be equal to, so we have to bring the 1 over here now. Bring over the 1. Bring over the e to the x times e to the y. So that becomes 1 minus e to the x times e to the y, which is really 1 minus e to the x plus y. So now this is on this side. So now we just need dy by dx to be the subject. So we divide by e to the x plus y. And so that's dy by dx. 1 minus e to the x plus y over e to the x plus y. Easy, soft, with a capital T. That's part C. All right, question 8 now. Question 8 tells us that the roots of a complex
Wait, sir.
Yeah, go ahead.
Now, I don't get how number 7 is actually C.
C. You don't get how it is C?
Yes, sir. I thought it would be D.
All right, so let's go through it again. All right, this is it. So look at it now. So just to be clear, what you can do is call this your U and call it your V. So your U is e to the x and your V is e to the y. Just to be safe. So now it's VDU, this is your V, and this is your DU, plus UDV. This is your UDV now. U is e to the x. Your dV is e to the y times dy dx, because we use implicit differentiation. All right, minus 1 equals 0. So now we need to make dy by dx a subject. So let's not jump.
So I get all of that right there, but I don't get all the denominator is
Yes, that's what I'm getting to. So I'm going to rewrite this now as this part. You can rewrite it as e to the x plus y times dy by dx. I'm going to write dy by dx as y prime, and that's equal to, bring over that as we were saying, we get 1 minus e to the x plus y. So remember, you know, in order to get y prime to be the subject, we have to divide both sides now by e to the x plus y. So we have to divide both sides by e to the x plus y. So now this cancel this. And so now that's how we end up get dy by dx to be this. That's more clear? That's more clear? Is that fine now?
yes, sir.
All right. So that's how we got dy by dx to be that. All right. Question 8. Question 8 gives us the roots of a quadratic equation ax squared plus bx plus c is equal to 0. And they gave us two complex numbers, 1 plus 2i and 2 minus I. And it says, what is the equation now of this quadratic? All right, so first and foremost, the equation of a quadratic can be written in a standard form. The equation of a quadratic is given by x squared minus sx plus p, and that's equal to 0. That's the standard form of a quadratic. And so it's really going to be x squared minus the sum of the two roots that they give us. So we need to add 1 plus 2i and 2 minus I. When we add them, what we get is 1 plus 2 is 3, 2i plus minus I is just positive I, so that is 3 plus I. So it becomes x squared minus 3 plus I times x. Then now this p is the product of the two roots plus the product of the two roots, which is 2 minus I times plus 1 plus 2i. That's equal to 0. So we already know the first part, so let's just work on multiplying this part now. So this times this becomes 2, this times this becomes 4i, this times this becomes minus I, and then this times this becomes minus 2i squared. Now I squared is negative 1, and so this becomes negative, which becomes positive, and so we have positive 2 plus 2 is 4. Then we have 4 minus I, 4i minus I is 3i. So we don't get 4 plus 3i. So we're looking for something that says x squared minus 3 times minus 3 plus I times x plus 4 plus 3i. That's what we're looking for. X squared minus, that looks like A. Yep, that's A. Easy question, soft, too easy. All right, question 9. Now, question 9 is just a knowledge question. They're just testing our knowledge to see if we can recall how to integrate trig.
Sir, that's dog.
Dog? All right. The dog is the answer. And let's just go through the proof of it. So we're integrating 1 over x squared plus 4. So we're integrating 1 over x squared plus 4. Now, how I'd like you to write x squared plus 4 is 1 plus 2 squared. Because there's a particular rule with integrating tan functions, tan inverse trig functions, is that when you're integrating, so this is the rule to remember. This is the rule. The rule to remember is that when you're integrating, the integral of a divided by a squared plus x squared dx, when you integrate this, the result is tan inverse of x over a. The result is tan inverse of x over a. So that's a rule to remember.
Wait, so you're sure?
Yes, this is right.
Or is the tan inverse of ax?
Yeah, this is tan inverse of x over a. How you can always know is differentiate it back. This is tan inverse of x over a. So anytime you can always differentiate this back to see if you get back this. All right, so right here now in the numerator, this numerator now, we need a a, or a in this case 2. So since we need a 2, we're gonna put a 2 in the numerator and put a half on the outside. So what we end up getting now is a half. Now this part, this integral part right here now is just going to be tan inverse of x over 2. So it's a half tan inverse of x over 2 plus some constant c. All right, and as I'm saying now, how to check back your answer, you can always differentiate this, differentiate tan inverse of x over 2, times it by a half, and you should get back this, just to check your answer. So if you wanted to check your answer, check. All right, so we had a half tan inverse of x over 2. That's dog. So dog is the answer. All right, easy stuff. Question 10. It says that we have some function f of x and it's equal to ln 3x squared. F of x is ln 3x squared. And they want the second derivative. They want the second derivative when x is minus 2. So we have f of x is ln 3x squared. So we just write down our f of x, which is ln 3x squared. So we're differentiating a log function twice and then plugging in the value of x being negative 2. So we differentiate it once. I'm just going to write f prime. We differentiate once, we're going to get 1 over 3x squared times 6x, because 6x is the differential of 3x squared. And so that simplifies to be this 6 cancels, well, this 3 cancels out a 3 from here. And so what we get is 2 in the numerator, because 6 over 3 is 2. X in the numerator divided by x squared is just 2 over x. We can write that as 2 times x to the negative 1. So that's f prime of x. And now we need f double prime of x. F double prime of x would be now to just bring down the power to get negative 2x to the minus 2. Subtract 1 from the power. And so what we end up getting now is minus 2 over x squared. But the question did not ask for the second derivative. It asked for the second derivative at a point. So I have to plug in x as minus 2 now to get minus 2 over 2 squared, and 2 squared is 4. And so what we get is minus a half. So we get minus a half. Nice and easy. Easy. So why maths is beautiful. Imagine you get something looking complex, and when you work it out, it just works out to be minus a half. So beautiful. That's the beauty of mathematics. Question 11. So we have another complex number question, and it is asking us to just find, write the complex number in exponential form. So to go from Cartesian form to exponential form, in Cartesian form, it is x is equal to a plus bi. That's Cartesian form. X is equal to a plus bi. That's a Cartesian form, or the rectangular form. And now we want to write it in the form re to the I theta. That's exponential form. All right, so all we need to do is find r and theta. But looking at the options, they already tell you that r is 2. R is 2. So the only thing we need to do now is find theta. Before we can find theta, look at this. Z is minus 1 plus root 3i. Minus 1 plus root 3i means that it is not in the first quadrant. If you're to sketch the Argand diagram, minus 1 is somewhere right, maybe right here, minus 1, and root 3 somewhere maybe right here. And so it is in the second quadrant. So this would be the complex number z. So since it's in the second quadrant, this is the angle that we want. It's the angle between the positive x-axis. All of this is the angle that we want. And so the argument, which is the angle that we want, is going to be so it is pi plus, this is for argument in the second quadrant, it is pi plus tan inverse of y over x. Now this is y is root 3, x is negative 1, so it's tan inverse of minus root 3. So it is pi plus tan inverse of minus root 3. So you take up a calculator and find tan inverse of minus root 3. Tan inverse of minus root 3 is minus 60. And so what we're getting now is pi plus minus 60. And minus 60 is really minus pi by 3. So it is pi minus pi by 3. And so therefore, theta is 2 pi by 3. So looking for the option that has 2 pi by 3. All right, so the key thing for this question is to just remember which quadrant you're really in. So if the angle is in the second quadrant, it is pi plus tan inverse of theta. If it's in the first quadrant, then it is just tan inverse of theta. If it is in the third quadrant, it is pi minus tan inverse, or tan inverse minus pi. Either way will give you the same answer. All right, so just depending on the quadrant that you're in, then you'll know how to find the argument. In this case, we're in the second quadrant.
But the angle is negative?
The angle is not negative. The angle is positive. Here's the angle. All of this is the angle.
So, but it's not, is why are this? It's not pi plus tan inverse of negative.
Yes, pi plus tan inverse of negative root 3.
Yeah, that must be negative.
Yeah, in here say negative, yeah. Yeah, I guess you worded it correctly. Right here, this angle is negative, but the argument is going to be, this is a key part now. The argument is always, just to remember, that's a brief reminder how to check your answer, that the argument of z is always going to be between pi and negative pi. So anytime you get an answer that's outside this range, check it over. Argument is always going to be between pi and negative pi. So that looks like 2 pi by 3 is C. C for cat. All right, question 12. Now, question 12 is asking us for the square root of 3 minus 4i. Now, I'm not going to tell you to do the long method to work out the square root of 3 minus I. I'm going to tell you the shortcut method to do it. The shortcut method to do it is to check the options. Look which options that when I square it, I'm going to get back that answer. All right, because if I ask you to find the square root of some number x, and I tell you that it is equal to n, and find n, then how to find n is I know that this is also true. N squared is going to be equal to x. So I'm not going to check this one. This one is too long for a multiple choice. I'm going to check this one. So let's go. They want us to find the square root of, I believe, 3 minus, let's look again, 3 minus 4i. The square root of 3 minus 4i. That's what they want to find. That's what they want us to find. Right? And so let's check the options. The options are these three. All right. Now, what I can tell you is not going to be A or B. How do I know that? There's just some, when you square the first term in this part, you're going to get positive 3. And because you're going to get positive 3, when you square the I part, you're going to get another number. So when you add them, that won't give you back 3. So automatically, A and B are going to be out based off observation. So only need to check CRD. So let's check CRD. All right, so we need to check CRD such that when you square it, you get 3 minus 4i. And so we check C, starting with C, just for arithmetic order. 2 minus I all square is equal to first term square minus twice the product of the 2 plus the second term square. All right, now I square is negative 1. And so negative 1 plus 4 is 3. And so we get 3 minus 4i. So if 2 minus I square is 3 minus 4i, then what that is telling me is that the square root of 3 minus 4i is equal to 2 minus I. So that's the answer, 2 minus I. Easy. That's question 12. Question 30. All right, so given A, B, C, and K are constants, you want to be finding the integral of 3 over x squared times x minus 1 dx. You want to be evaluating this integral. In order to evaluate this integral, you have to break it up as partial fraction. So that's what we have to do. So first and foremost, the integral of 3 over x squared times x minus 1. I'm going to leave off the dx, but never leave off the dx. Never leave off your dx. So let's not leave it off then. Now this is going to be equal to, no, we have to use partial fraction to separate it. So it would be a over x, the first part is linear, plus the integral of b over x squared plus the integral of c over x minus 1. That's how you'd have to integrate it. Where then you'd have to find a, b, and c. using partial fraction. Now the integral of a over x is just a ln x. Because we could factor out this a and have the integral of 1 over x. And integral of 1 over x is ln x. Now we're integrating b over x squared. Integrating b over x squared is really, this is really bx to the minus 2. That's really bx to the minus 2. So what we're getting is we bring down the power, carry down the power, well, not carry down the power, add 1 to the power, my bad. So we add 1 to the power and divide by the power. So we add 1 to the power, and we get x to the minus 1, and we divide by the power. So it is plus bx to the minus 1 divided by minus 1. Then when we're integrating c over x minus 1, it is just plus c ln x minus 1. C ln x minus 1. Now this bx to the minus 1 over minus 1, I can just write it as minus b over x. Minus b over x. So that's what we're looking for. We're looking for answer that is a ln x minus b over x plus c ln x minus 1. That's what we're looking for. That's D. A ln x plus b over x plus c ln x minus 1. Notice that right here it's positive. This is a positive. The only reason why they can put a positive plus b is because let's say we call this, let's call this minus b right here, b. You could call this minus b plus b, right? And then it would work out to be the same, all right? And so that is why that's a plus b there. So don't be thrown off by the plus b. This is the answer. So that's
So where's the article, sir?
I'm saying don't be thrown off that because they have plus b, and when we work it out, we have minus b. Don't be thrown off by that fact. The only reason why they can have plus b is because b is a constant, right? We don't know what that constant is. So they could then say, let the small b be equal to negative big B. And let small a be equal to this big A. And let small c be equal to that big C. Then you would see that what you get is small a ln x plus small b over x plus small c ln x minus 1. So that's all I'm saying.
Sir,
That shouldn't be legal, sir. That should not be legal.
Why is this not? Why this shouldn't be legal?
Sir, because all we are doing difference between small b and big B, sir. Yeah, must be the same thing.
No,
I'm
it's
not gonna that.
yeah. This is all they did. That's all they did.
So I'm not gonna make that, sir.
Yeah,
It's
yeah,
the same thing.
it's the same thing. So that's why they put plus b. So all they're saying is that this plus b is just equal to negative big B.
sir.
Yeah.
For the in the question we have plus integral of b over x squared, right? Where the x squared gone in the second line in the next line after that we have a
In
ln x.
this line right here.
Yes, sir.
All right. So when you integrate bx to the minus 2,
Yeah, I know you're gonna get instead of the plus 1, so you get -1. Oh,
you get,
never mind. Yeah, I see. No,
yeah.
yeah.
Integrate bx to the minus 2, you get
Yeah,
b.
we'll just add 1, you go get x to the -1, and you put that down and go get b over x.
Exactly.
Yeah.
So that's what happened. All right. So that's dog. Easy question, soft. All right, question 14. It's asking which of the following is true. Now there's an easy way to do this question. I wouldn't want you to be, in order to find f of x, you'd have to integrate. You'd have to integrate with respect to x, the first one, in order to find f of xy. This one you'd have to integrate with respect to y to find f of xy. Now, that is too long to be integrating these stuff, right? That's too long. So what I'd advise you to do is look at the options. Instead of integrating, look at the options and see which one, when you differentiate, you get these answer. All right, so now looking at this, f of xy. So if f of xy is the first one, sine of x plus y, when you differentiate this with respect to y, when you differentiate sine, you should get cosine. Now there's a sine right here. So A cannot be the answer. A is out. A is a big wrong. No. A is out. Because when you differentiate sine with respect to y, you should not be getting back sine. So you can check B now. E to the x cosine x plus y. When you differentiate cos, you get minus sine. And then when you're differentiating e to the xy with respect to y, so let's write it down. So we're using the second one where we're looking at f of x is equal to e to the x times, or not f of x, f of xy. F of xy is equal to e to the x times the cosine of x plus y. So this is an easier way to do it. Check the options. So what you would get is that f of y, so differentiating with respect to y, the first derivative with respect to y, e to the x is a constant. So put back our e to the x, then we'll multiply it by, we differentiate the cosine of x plus y. We differentiate cos, we get minus sine of x plus y. Easy. And you finish. Now that was the answer you had. They just put the minus on the outside to write it as minus e to the x times the sine of x plus y. That's all they did. That gives you fy, or dou f by dou y. There it is. So the answer is B. Now you can go even further. Let's say you don't feel comfortable with that. Now you can go further and find that when you differentiate this one, when you differentiate it with respect to x, you should get this in the top. So if you don't feel comfortable by just doing one partial derivative, you can find the partial derivative with respect to x by keeping the first, then you differentiate the second. You differentiate cosine, you get minus sine. So you get minus the sine of x plus y plus, keep the first, differentiate the second, plus keep the second now and differentiate the first. So you get e to the x times the cosine of x plus y. And all they went further to do is then factor out e to the x. And if you factor out e to the x, you get minus sine of x plus y plus cosine of x plus y. That's what they had. But from you find that one partial derivative is true, more than likely both partial derivatives are going to be true. So remember, this is the MCQ and you want to maximize the time. So it's not necessary to prove both. Here it is, minus sine plus cosine. It is B. All right. All right, so question 15, it says, if f of x is a continuous function, which of the following is true? If f of x is a continuous function, which of the following is true? Everyone, well, most persons should know this one. So just tell me which one is the answer. Anybody attempt it?
Sorry, let me see if I can try it. Sorry.
Come on, somebody. One brilliant student.
Sorry, what do we see, sir?
Repeat.
See, I think you see, but I'm not sure. I'm not sure my answer, but I think you see, but I'm not sure if that's what.
Come on, man. Come on. So how did you do the assignment? I sent you assignment where you had to use this.
Yeah, yes, sir. I remember B. I remember using B.
Yes, B is the answer, clearly. In order for a function to be continuous, the second partial derivative, when you differentiate it with respect to x first, then differentiate it with respect to y,
You switch
it
it
should be
and
equal
differentiate.
to
Yeah.
the same thing as differentiating with respect to y first, then differentiating with respect to x. Because then if it is continuous, it doesn't matter the order in which you differentiate it, you should get the same derivative. For example, let's look at a simple example. Let's say f of x, xy is equal to, let's say it is equal to
I'm back again.
All right. Let's say it's equal to x squared plus y squared. So we're at question 15. So we have f of xy is x squared plus y squared, right? If you're to find the second derivative, differentiating this respect to x first. So if you differentiate it with respect to x first, you get fx is equal to 2x. All right. If you're to differentiate this now with respect to y, you get that fxy would be equal to 0. Now let's check something now. If you differentiate now with respect to y first, you get 2y. And then if you differentiate with respect to x next, so fyx, you get 0. And so what this is telling you is that x squared plus y squared is continuous when the second derivatives are equal. No matter what is the order, it is continuous. So you can make up some function now, f of xy, and not all the time it's going to be continuous. So we know that, for example, if it's a trig function, it's going to be continuous. If it is a polynomial like this example, it's going to be continuous, because all polynomials and trig functions and exponentials are continuous, right? So this is the most important one, right? The most important thing to remember about partial derivative is that they're second derivatives. So in order for a function to be continuous, fxy must be equal to fyx.
Fyx.
All right. So I put that on an assignment, I remember. And I asked you to find some second derivative, and then I said, hence determine if it was continuous. That assignment, I call it entertaining assignment. It was very nice. And only one person sent in that assignment, just to be clear. All right, so that's question 15. Easy stuff. All right, question 16. Question 16, that's not 16, that's 23. Question 16. It says, which of the following sequence is the first 4 terms an arithmetic progression? So which one it is?
That looks
which
like
one?
A.
That
No,
looks
no.
like A?
Dog.
Dog? Why you say dog?
Because each term is the common difference between them is -2.
-2. That's how you know when it is a GP
Arithmetic.
from an AP, is that a GP of a common ratio. So in the first one right here, this is a common ratio, right? T2
yes, sir.
divided by T1 is giving you a common ratio. Now
So
the last
A
one
is
right
a GP.
here, yes, so A is a GP. Now this is the arithmetic progression, all right? Because it have a common difference of -2. And so D is the answer. because it have a common difference of -2. That's dog. Easy question. Now part C. This is just something, let's shade the answer. What would this be? What's the value of x
Cat.
in order for this to be convergent? Cat. Why is it cat?
Because a convergent series of for a convergent series, x is between -1 and +1, sir. For it
X
to
is
be
between,
convergent.
x is between -1 and +1 in order for it to converge. Now I just want to point out that it cannot be equal to 1, because if it's equal to 1, then it's not going to be converging. Just to point that out, if it's equal to 1, it's not going to be converging. And so as you rightfully said, it is cat. All right? It is cat because for a GP, the common ratio, for a GP, the common ratio R has to be less than 1. The modulus of the common ratio R have to be less than 1. So that's telling you that R has to be between 1 and -1. Now, how did we actually find this common ratio now is that if you're taking the summation from R being equal 0 to n of x to the R, if you're to write this out in terms of the actual terms, when R is 0, you get 1. When R is 1, you get x. When R is 2, you get x squared, and you continue. And so the common ratio is R is equal to T2 divided by T1, which is x over 1, which is x. And so therefore, x has to be between 1 and -1 in order for it to converge. So that's cat. Easy question. Now question 18. Question 18 says a sequence is defined as U1 is 2, U2 is 4, UN is UN minus 1 plus UN minus 2. Now what is this going to be?
All right, so I'm going to find U3 first, sir.
All right, so what is U3?
U3 is going to be equal to U2 plus U1.
Yes, which is?
So it's 6.
All right. So that's
So
U3.
it keeps increasing, sir. So therefore, divergent.
Very good. So it's a divergent sequence. It's going to keep on increasing. All right. So it's going to keep on increasing. And so therefore, this is a divergent sequence. Very easy question. Too easy. Soft. All right. Now question 19. Question 19 says an plus 1 is equal to an minus an minus 1, where a1 is 1 and a2 is 3. So what's the value of a5? So how are you going to find the value of a5?
Yeah, but I need to find A4.
There you go. All right, very good. That's the idea. You're going to have to find the terms that are before a5. So
Yes,
you know a1 and a2, you're going to have to find a3, then a4,
and A4.
then you can find a5. All right, so we have an minus 1. So it is an minus an minus 1. Now, before we can find a5, we need a3 because they gave us a2 and a1. So a3 is going to be equal to a2 minus a1, which is 3
A2
minus 1.
Which is
What
2.
is a3? a3 is 2. So if a3 is 2, what is a4?
A4 is going to be A3 minus. Wait, no, A4. No, A3
You're right.
minus
A3, A3 minus
A3
A2,
minus A2.
which is 2 minus 3, which is
Negative 1.
1. So now we can find A5. What is A5?
A5. That one n equals 4. So it's A4 minus A3.
Exactly. So it's
So
minus
it's
1,
-1 minus 2, which is minus 3.
minus 3. Very good.
So what option is that now?
That's A. A as in,
Apple.
no, since we're using animals, you cannot say apple. You have to use a,
That's ridiculous, sir.
yes, we said bat, we said cat, and we said dog. So what is A?
Ape.
All right, that can work. All right. Now you're talking. Cannot be apple. So now question 20. It says we have the Maclaurin series expansion for sine x. So what's the Maclaurin series expansion for sine x?
Sir, f of x is equal to f of 0 plus f prime of 0 over 1 factorial times x plus f double prime of 0 over 2 factorial times x squared.
Very good. So f of x is equal to f of 0 plus f prime of 0 times x plus f double prime of 0 times x plus f double prime of 0 f double prime of 0 times x squared over 2 factorial, and 2 factorial is 2.
Yeah.
Plus f triple prime of x, f triple prime of x, f triple prime of 0 times
0
x cubed
over 6 times x cubed.
over 6. Very good. Now if f of x is sine x, when you f of
F of
0
0
is
is
going to be
going to be
sine
0,
of
sir.
0. Sine of 0. So let's write it down where f of x is sine x. F of x is sine x. And so now f prime of x is when you differentiate sine, we get cos, and the cos
Cosine
of
x.
0 is 1.
Yes, sir.
So we get plus x. We differentiate cos, we get minus sine, and
Minus sine x times 0.
which is minus 0, plus,
Minus 0.
when we differentiate now minus sine, we get negative cos.
Negative cosine.
All right, so negative
And the
cosine.
cosine of 0 is 1. So negative cosine 0 is negative 1.
So we get
So the answer
negative.
is, right there says minus 1/6 of x cubed.
Okay, very good. And so this just works out to be x minus
X
x
minus
cubed
x
over
over
6.
6.
Now I'm going to show you something, right, that we should be familiar with from complex number is for all exponentials, right? For all exponentials, e to the x, right, is equal to, this is just something I want you to remember. E to the x is equal to 1 plus x plus x squared over 2 plus x cubed over 6. Well, 3, let's write 3 factorial. So there's a way to find out what is e to the x. E to the x is 1 over 0 factorial plus x over 1 factorial plus all the way up to x to the n over n factorial. That's e to the x, right? That's e to the x using Taylor or Maclaurin series expansion. Now look at this. The sine of x now, sine of x and cosine of x is very connected to e to the x. The sine of x is equal to, no, sine of x, think of odd numbers. Odd numbers start from 1. So it is x minus x cubed over 6, which is 3 factorial. And then you alternate the sign. It's going to be plus x to the 5th over 5 factorial, minus x to the 7 over 7 factorial, and it continues. All right, so this is just some fun facts. So this is fun facts. You don't have to know it, but it's fun facts. Fun facts. And there's a reason why I'm showing you this, is I want you to do something and send it to me as a homework. You don't have to do it, but if you do it, I'd be really happy. So the cosine of x now is going to be 1 plus x squared over 2 factorial minus x to the 4 over 4 factorial plus x to the 6 over 6 factorial. We're catching the pattern?
Yes, sir.
Then it would have been minus x to the 8 over 8 factorial. Now here's the homework now that I'd love you to try. What I'd want you to try now is to prove from these facts, these would continue of course, to try is proof that e to the I times theta, so from complex numbers, we'd have learned that e to the I theta is equal to cosine theta plus I sine theta. I'd want you to prove this now, given those facts. So this is how they link now exponential. This is how they link the complex number from exponential form to this form, which is a polar form. It's by following Taylor series or Maclaurin series. So I want you to use these principles in order to show that e to the I theta is equal to cosine theta plus I sine theta. So that's a nice homework to do. That's a fun fact. Nice homework to try, right?
Sir, number 20, please.
All right, let's move on. All right, so x minus x cubed.
X cubed over 6. Oh, boy.
Yeah, that's so boring. You don't even want to try the homework. All right, let's go. So now, this question asks us, it gives us that un plus 1 is equal to 1 minus 1 over 1 plus un. And so find the 20th term. There's pretty much going to be a pattern. So u1 is 1. And so we need to look at the pattern that we're going to be getting consistently.
Un equals to n.
So u1 is equal to 1. And so u2 is going to be equal to, it says it's equal to 1 minus 1 over 1 plus un. Now in this case, n is 1. un plus 1 is 1 minus 1 over 1 plus un. So in this case, when n is equal to 1, this is 1 over 1 plus 1, which is 1 minus a half, which is a half. That's when n is equal to 1. So when n is equal to 2 now, we're going to get that u3 is equal to 1 minus 1 over 1 plus a half.
U2, which is a half. So
now
1
plus
over 3 over 2.
3 over 2. This works out to be now what?
2
over
thirds.
3,
1 minus 2 thirds.
which is 1 over 3.
Yes, sir, 1/3.
All right. So if you were to continue all the way down now to work out what is
un, sir, is equal to 1 over n.
the 20th term is u20. u20 is when n is going to be equal to 21. When n is going to be equal to 21, what we get is 1 over n plus 1. So it's 1 over 21.
1 over 21, sir?
1 over 21. Wait, 20, sorry.
Oh,
Yeah, I'm so
okay.
sorry about that, sorry. U3 is 1 over 3, U2 is 1 over 2, U20 is 1 over
1
20.
over 20. Okay.
Yeah. I don't know why 21 was in my head. Probably because we're doing question 21. So 1 over 20. So for question 21, it's not 1 over 21, it's 1 over 20. Question 22. Now, question 22 is asking us for the difference. We have to use now the difference.
So I'm afraid answer, Dina. I'm afraid we do this early.
Well, we did the question with the sum of 1 over r plus 1 minus the sum of 1 over r. Now them switch it up and put 1 over r minus 1 over r plus 1. And so they love to do that. Sometimes you'll say 1 over r plus 1 minus 1 over r, and next time you'll see the sum of 1 over r minus 1 over r plus 1. So they love to switch it around. So you have to be very careful. So let's look at it using method of differences. So we want the sum. So we want the sum of 1 over r minus 1 over r plus 1. And it starts from r equal 1 to n. From r equal 1 to n. So plugging in r equal 1 for this side, of course we can break it up as two sums, which is the sum of 1 over r minus the sum of 1 over r plus 1. So break it as two summations, and then we get that it's equal to now, we plug in 1, and we get 1 plus, we plug in 2, we get a half, we plug in 3, we get a third, and we continue until we plug in n to get 1 over n. So that would gives us that sum. Minus now, the sum on this side would be, we plug in 1 to get a half, plus a third. We'll keep on doing that until we add all the way up to, now look at this, if you're to plug r as n minus 1, n minus 1 plus 1 is n, so you
1
get
over n.
n, plus the final term is 1 over n plus 1. And so if you're to subtract them now, you notice that a half is going to cancel the half.
Yes.
Everything is going to cancel from here. 1 over n, cancel this 1 over n. And so what we're left with now is just
1 plus 1 over n plus 1.
1 minus 1 over n plus 1.
1 minus 1 over n plus 1.
Very good. And so what we're left with is n plus 1.
N plus
minus
1 minus 1
over n plus 1.
And that gives
just
n over n plus 1.
So you were right. It was D. You were correct.
Yes, sir.
Just D. That's dog. Nice and easy.
Nice and easy. No, not
Soft.
that.
Soft. All right. So now we're more than halfway through the paper now. We're at the halfway stage for this paper. So the sum of the first n terms of a geometric series. Now to get the sum of the first n terms, right, you want the sum of n terms, so that's Sn. So Sn is equal to 1 minus a half to the n. That's what they're telling us. Sn is 1 minus a half to the n. Sn is equal to 1 minus a half to the n. 1 minus a half to the n. So that's Sn. Now let's look what else they told us about it. They told us now they want the value of the second term. Now first and foremost, Sn is the sum of n terms. And so if you want the second term, that is just S2, the second term is always the first term plus the second term. That's S2. And in this
So
case,
the sum of the first two terms
yes,
is A1 plus A2. That's the
A1 plus
second term.
A2. Yeah. First term plus the second term. And that's equal to 1 minus a half squared. And 1 minus a half squared is going to work out to be 1 minus a quarter. And 1 minus
Which
a
is
quarter
3/4.
is 3/4. So that gives S2, which is A1 plus A2. Now, if we're to take the sum of just the first term, it would be 1 minus a half, which is a half. And so now look at this. The sum of the first term is a half, and the sum of the first term is just A1. So now that we know what A1 is, then we have a half plus A2 is equal to 3/4. And we need that second term. So a half plus A2 is equal to 3/4. All right. Just for simplicity, we're going to write 4 over A2 over 4. That's still A2 by itself. And I can write a half as 2 over 4.
8 over, huh?
I'm going to write the half as 2 over 4.
2 over 4, yes, sir.
So what we're telling you then is that 2 plus 4 A2 is equal to 3. And so therefore 4A2 is equal to, subtract 2 from both sides, I get 1. And I'm getting
A
A2
quarter.
is equal to a quarter. Easy, soft.
Okay.
No calculator needed, soft. Easy. All right. Now question 24. Question 24 asks, where is there a root between? So in order to find where a root is between a particular interval, we use
One of them have to be
IMVT.
positive, and one of them have to be negative, sir.
Exactly. So we use IMVT. So let's say you have some quadratic curve like this. Erase away this part. Let's say we have some curve like this. Then you have A and you have B. A root is right here, but the only way a root lies on the interval AB is if f of A is less than 0 and f of B is greater than 0.
Greater than 0.
So that's when a root lies on the interval AB. So in this case, they gave us the function e to the something, e to the x minus x to the 4. So we have e to the x minus x to the 4 equal to 0. So there are two ways you can do this question. You can use IMVT and try values. If you're to plug in f of 0, you're going to get e to the 0, which is 1, minus 0. So plug in 0. So what we'd get right here is that f of 0 is equal to 1,
Chile.
which is greater than 0. So then we'll plug in 1 right now, and then we get f of 1 is equal to e to the 1 minus 1. That's also greater than 0. E to the 1 minus 1 is just e minus 1. That's also greater than 0 because e is 2.7. And so therefore no root lies on that. Because if you're to sketch this graph, right, you have 0 and you have 1. You have f of 0 is 1, and then you have f of 1 is somewhere here. So now, so this is the curve. Clearly can't cut the x-axis in between 0 and 1. All right, so next we need now is f of 2. F of 2 is going to be equal to e squared minus 2 to the 4th power. E squared is 8 point something minus 2 to the 4th power, which is 16. That's less than 0. And so since 1 is greater than 0 and 2 is less than 0, then the root lies between 1 and 2. So the root, let's call it alpha, lies between 1 and 2. So that's the interval where the root lies, between 1 and 2. That's one method to do it. Another method to do it is actually solve it and find the root, and then you can get the answer. So if you want, you could just solve, when is e to the x equal to x to the 4? Then you take logs of both sides, and then make x be the subject.
Why that long? That's a long method.
Yeah, that's another way you could do it. So you'd find the root, you'd end up get 1 point something, and 1 point something is between 1 and 2. So that's the long way to do it. Now, this now is asking for the binomial coefficient of this.
No answer is boy.
Boy, this one is clear. There's just a easy stuff to remember from combinations, that n choose r is equal to n choose n minus r. So many times to remember it. N choose r is equal to n choose n minus r. Easy, soft. All right. Question 26. Question 26 asks for the value of the term independent of x in the binomial expansion of x squared plus 1 over x to the 12th power. So we want the value of x. Now we want the value of the term that is independent of x. All right. So what they're asking you is for the constant term. So look, again, we have x squared plus 1 over x to the 12th power. So what you do, you have x squared plus 1 over x to the 12th power. And I want, not to the 4th power, to the 12th power, sorry. So what I want to do is, when you expand this, we know that we're going to get 13 terms, right? When you expand x squared, you get 3 terms. You expand cube, you get 4 terms. We know we're going to get 13 terms. But we only want the constant term. The last part, we're going to say the plus c. We want to know what that c is. The only way we're going to get a constant, meaning that what we're going to have is x squared raised to some power, or multiply it by 1 over x raised to some power. The powers must be in such a way that when them supposed to cancel out each other, so that the x squared raised to the power cancel out the something of x to some power, right? So we need that to be a constant. Now looking at it, this is 12, right? So the only way that can be is if we raise this to the 8th power and this to the 4th power. And so this is choosing 8, 12 choose 8. Think about it, because this part now end up be 12 choose 8 times x to the 8, because x squared to the 4th power is x to the 8. And then we divide it by 1 over x raised to the 8th power is just x to the 8. And so x to the 8 cancel x to the 8, which just leaves 1. And so you're just left back with 12 choose 8. So 12 choose 8 is the answer. But I guarantee that 12 choose 8 is not going to be there. See it there? 12 choose 8 is not going to be there. Now from the question above, we just learned that n choose r is equal to n choose n minus r. So use that. So 12 choose 8 is going to be equal to 12 choose 12 minus 8. Because this here r is
12
8.
choose 4.
It's 12 choose 12 minus 8, which is 12 choose 4. So that's the answer. 12 choose 4. 12 choose 4. So 12 choose 8 equal 12 choose 4. Easy.
Trick there.
Soft. Not even a trick. right? Tricks are for kids. They can't trick us. We're in sixth form. That's too easy, right? They can't trick you right there. Come on, man. Question 27. Now, they're asking for the coefficient. My bad. They're asking for, why is this jumping so much? The coefficient of x cubed in the expansion of 6 minus ax to the 9th power. They want a coefficient of x cubed. So they just want a coefficient of x cubed. So to find, and they told us that the coefficient.
Yeah, that's the fourth term.
That's the fourth term, all right? And so the coefficient of x cubed is just going to be, well, let's write out what the expansion was again. It is 6 minus ax to the 9th power, 6 minus ax. I have a good feeling that this is going to come back. This same question. 6 minus ax to the 9th power. The only thing is that I have a feeling that they're not going to put that. They're not going to say that the coefficient is negative 84. I have a feeling it's just going to say 84. I just have a strong feeling. So the coefficient of x cubed in this expansion is negative 84. Now, first and foremost, the coefficient of x cubed is the fourth term. And this fourth term, I'm going to call it t. And let's just write it. Fourth term t is equal to, it's going to be 6 to some power x cubed term times minus ax to the 3rd power, and so this has to be to the 6th power, and so we're choosing 3 from 9. So that's the fourth term, and they told us that it's equal to negative 84x cubed. Easy. So now let's put this in a calculator. Simplify it. So first and foremost, if we're going to simplify this, this is really just 9 choose 3 times 6 to the 6 times minus a cube times x cubed. And that's equal to minus 84x cubed.
So if you put the negative sign behind the 9 choose 3, you're not going to have it.
Yeah, bracket it. When you put it in a calculator, bracket it.
Like, it'll look confusing, sir. I think you'll subtract.
Yeah, bracket it. Bracket it. Repeat.
Okay. But watch already. Well,
all right.
Okay.
And so now we just make A the subject from right here. Now look at this. This minus sign right here cancels this minus sign here too. And so what we end up getting is now a cube is going to be equal to 84 divided by 9 choose 3 times 6 to the 6. That's a cube. And so to get a now, you just need to take the cube root of both sides. So when you work that out, you're going to get a cube is equal to something, and you take the cube root of whatever that thing is. So a cube is the cube root. A is now, a is equal to the cube root of this right here. So we take the cube root of all of this long thing, 84 over 9 choose 3 times 6 to the 6. You put all that in a calculator, you get 1 over 36. That's a cube. Easy. All right. Now look at this question. It says now, find the coefficient of x to the 4th power in the Taylor series expansion of f of x equal to cosine x. Now look at this now. Look why these things come in handy. Remember I said this is f of x. All right, this is f of x. All right, and they want the coefficient of x to the 4 in cosine x. Now this is it. This is x to the 4 in cosine x. All right, and so the coefficient of x to the 4 is just 1 over 4 factorial. And 1 over 4 factorial is 4 factorial is 24.
Yes,
So
sir.
instead of, if you just know that formula, it makes it easy to can tell the coefficient. Easy. That's 1 over 24. That's 28. Let's go to 29. All right, question 29. Question 29 says, find the values of x for which the series is valid. Now, look at this question. First and foremost, I cannot square root a negative number. Right? That's the first thing. So in the denominator, the only way this is going to be valid is if that this number is going to be. So in this denominator, look at it naturally. In this denominator, in order for me to be able to can find the square root, in order for me to can be able to find the square root of 100 minus 5x, so ignore the numerator part. In order for me to can, is it 5x or 50x? That's 50x.
50x.
Very good. So in order for me to can find the square root of 100 minus 50x, first and foremost, we know what we know about square root is that when you square root something, it has to be greater than or equal to 0. And so if I square both, and in this case, it can't even be equal to 0. Tell me
Greater
why
than 0.
it cannot be
Because it's
equal
in the
to 0
denominator. So
as it in
if the
the
denominator is
denominator.
0, it's going to be undefined.
Undefined. Very good. So we can square both sides to get 100 minus 50x is equal to 0. So from this, we're getting that 100.
Sir, remember they can
Wait,
equal
greater. Sorry.
greater than.
Why this sign? I don't know why I put equal right there. My bad. That's greater than. And so this is telling me that 100 is greater than 50x.
So 50x is less than 100. So therefore, x is going to equal to x over less than 20.
Less than what? 20?
2, sorry.
I divide 2 by 50, I'm getting 2. X has to be less than 2. But
Less
no,
than 2.
this doesn't give you the entire solution range. So this is the important part now. This doesn't give you the entire solution range. Now, look at this. X is just less than 2, right? We just have that x is less than 2. No, none of them is going to tell you x is just less than 2. So binomial expansion would actually give you the correct thing. But what I'm saying is from this short method, when you do this, if x is less than 2, then you can conclude this. Then the modulus of x is less than 2. All right? And then if the modulus of x is less than 2, then x is going to be between, what's x going to be between? 2 and
negative 2.
All right. So this is one way to do it without having to use binomial theorem. So again, you could have used binomial theorem by writing this as 100
100 minus 50x to the minus half whole.
to the minus half. Yeah, the square root of it, all of that raised to the minus half. Then you can
And then you'd have to factor out 100.
factor out 100.
So it's going to be 100 to the minus half
100 to the
times
minus half times
1 minus a half, all of that raised to the minus half.
1 minus a half x to the minus half. And then therefore from this, by binomial theory, then a half x is between 1 and negative 1.
Yes, sir.
And then you
And
multiply
therefore,
it by
x
2.
multiplying by 2, sir, x is going to be between negative 2 and positive 2.
Exactly. So that's using binomial theory. However, you can just use common sense in the sense that we know that when you square root a negative number, that can't happen. All right, else you can't get a real number when you square root a negative number. So you could just use this principle to find the range of values of x. So that's but. All right. Which of the following is true? Just tell me this answer. It's too easy.
So the following is true. This look like boy.
This look like boy.
I cannot else.
And this look like C.
Look like C.
No, sir, that is not true.
Come on, man. Come on.
This is a
All
design.
right. So it is actually dog.
Yeah.
Dog is
Oh,
an
that's it.
answer. That's what I'm going to show now. So dog says the sum from R. How to do this question, you can actually use examples, but the sum from R equals 0 to n of R squared is equal to the sum from R equal 1. It's the same.
Oh, okay. If I make R equals 0, 0 squared is just 0.
0 squared is just 0. It's not going to change the value. So when you
Oh,
plug in
yes. So
0,
you're not going to
you
change
get
it for
0
real.
plus. You plug in 1, you get 1. You plug in 2, you get 2 squared. And adding all the way up to n squared.
Square.
And that's going to be equal to the same thing as over here. Over here is when you put in 1 squared.
Plus 1 square plus 2 square plus all the way up to n square.
Plus all the way up to n squared.
Okay. I never thought about it that way.
So the 0 don't change the value. The sum, so just think about it naturally. The sum from 1 to 5 is add 1 plus 2 plus 3 plus 4 plus 5. But the sum from 0 to 5 are the same thing. Right? So that's the trick right there. All right, so it is dog. Easy question. Now the sum from 1 to n of 2 is 2 times n. So right here should have been an n. Because you'd be adding 2 n times. So that's with C.
The summation of a constant is the constant times n.
Yes, because you're adding the constant n times. So that's why C is out. It couldn't be B because there's no summation law till that that the square of the sum is the sum of the square. No summation law tell you that. You have to make up this one for B to be true. If this was now the sum of the log of R squared, then the first one would have been true. But because there's no log there, you cannot bring down the power. So that's why A is out.
Yes,
nice
sir.
Question. Nice question. All right, question 31. Easy question. Just look at it and tell me the answer.
We'd have to find, all right, so that'll be m squared minus 3m plus 2
M square.
A.
A is the answer. Very good. You can just look at it and tell, because this is going to have two real roots when you solve the auxiliary equation. So if you were to write down the auxiliary equation, it would be something like u squared minus 3.
Minus 3m plus 2.
Yeah, plus 2. And so you get u equal 1 and u equal 2. And then we know the general solution when u is equal to 1 and u is equal to 2.
A times e to the m1x plus b times e to the m2x.
Very good. So it's y is equal to a e to the x plus b e to the 2x.
2x.
Very good. So that was a question to just look at it and say, oh, A. Easy, soft. Question 32. Question 32 tells you that PQ is 21i. That's what they're telling you.
Yes,
So
sir.
they're telling you that PQ is equal to 21 times the identity matrix. 21
Sure,
times.
I could clearly see that.
That's what they're telling you. Easy stuff. Then they want P inverse. You don't need to do anything with matrices. You can do this question with algebra. First thing, make P the subject. Make P the subject is just 21 over Q. That's P.
21 over Q.
Times I. Agreed? I divide both sides by Q. So then P inverse is 1 over P, which is now 1 over all of this. Now, when 21 over Q would just mean that I flip it to get Q over 21. Q over 21. Now, the identity times something is just that thing right there. So it is just 1 over 21 times Q. One over 21 times Q. That's P inverse. One over 21 times Q. Easy, soft. All right, question 33. Question 33 asks for the number of distinct permutation of the letters of the word possibility. What's the answer?
C.
C. Why is it C? Ashley, why is it C?
Because we have 11 numbers, 11 letters, which is 11 factorial over, and we have repeated letters, which we have 2 S and we have 3 I. So it will be
very good, very good. Very, very good. So it is cat. Very good. So cat is the answer. Because we have 11 letters, like Ashley said, and we have 2 repeated letters in S and 3 repeated letters in I. So it is 11 factorial over 3 factorial times 2 factorial. Easy question. All right. Question 34. Now, question 34, it tells us M is equal to this. So what's the first row of the cofactor matrix? So we need to find the cofactor matrix, the first row. So we need a cofactor of 1. The cofactor of 1 would be 4 times 6, which is 24 minus 5. So it is 19. Am I right?
Yes, sir.
And so therefore you done already to C. Because you don't need to find the other. There's only one of them with a positive 19, right? Yes, only one option with positive 19. So you already finished. Easy, imagine that, soft. Nothing to do right there. All right. Now here's a question that tells us that a sample space S consists of 3 mutually exclusive and exhaustive events. Mutually exclusive, so they never intersect. exhaustive means that the sum of the three probability is 1. And so if PQ is 0.3 and PR is 0.6, find 0.S. The three of them need to be 1. And so 0.3 plus 0.6 is 0.9. And so 0.S has to be 0.1 in order for these three to be add up to be 1. That's clear? This one is fine?
Yes, I got you.
Yeah, easy question. All right. Now question 36 says, in how many ways can a student council consisting of 8 students be formed from 40 students if 2 students must be on the council? So 2 is already chosen. 2 is already chosen. All right. So let's say Rajay is chosen and Ashley is chosen. And I need to choose 6 more persons, right, in order for it to be 8. So if I need to choose 6 more persons, how many left back that I'm choosing from is 38.
Yeah, 38 through 6.
So it is 38 through 6. Because them 2 persons, they're sure. For them spot put on already, right? So it is A. Easy question. All right, question 37. It says X and Y are mutually exclusive. If X and Y are mutually exclusive, that means they never intersect. And so the probability of X, which is a quarter, and the probability of Y, which is 1/5. So we need to find the probability of X union Y. So all we have to do now, I like when we just draw a Venn diagram. Mine is awful. Make sure yours is not. Like when we draw it, this is Y and this is X, right? So the probability of X union Y is going to equal to the probability of X plus the probability of Y minus their intersection. But when it's mutually exclusive, they never intersect. And so we're subtracting 0. So we're just going to be adding a quarter and adding 1/5. So adding 20% and 25% is 45%, which is 0.45, which is 9/20. It's easier to add in percentage and decimals than convert back to fraction. If you don't have a calculator, otherwise just put in a calculator. 9/20. C. All right. Question 38 follows laws of algebra. They want the determinant of h squared. This is easy. This is just some, you don't even need to actually use matrices, but the determinant of h squared is just equal to the determinant of h all squared. So we know this. All right. For example, if, I don't know, if you use h as 5 squared, and you take the modulus of 5 squared, you're just going to get 25. And it's going to give you the same value as if you were to find the modulus of 5 and then square it. You're going to get the same value. If you don't feel comfortable with this proof for the answer, what you can do is make up some matrix H, make up a 2 by 2 matrix. You can make it up as 1, 2, 1, 1. Just make up a matrix H and then find out the determinant of H. The determinant of H in this case is 1 minus 2. 1 minus 2 is minus 1. And so therefore the determinant of H squared, determinant of H, then you square it, is minus 1 squared, which is 1. Then now if this is H, you can work out what is your matrix H squared. Your matrix H squared is going to be H times H. So H times H, which is 1, 2, 1, 1, multiplied by 1, 2, 1, 1. You work those out to get row by column is 1 plus 2 is 3. Row by column, 2 plus 2 is 4. Row by column, 1 plus 1 is 2. Row by column, 2 plus 1 is 3. I don't know if that is right. Correct me. The determinant of 8 squared in this case would be 9 minus 8, and 9 minus 8 is 1. Now observe that the determinant of 8 squared is equal to the determinant of h all squared from these two. So when you use an example, you see that it is the same thing. Where you could have just used algebra, because matrices are going to generally follow the properties of algebra. And so that's why you didn't have to even work it out. Now question 39. It wants the determinant of the matrix M. So to find the determinant of the matrix M, we're going to be using row 1. Don't have to use row 1. Can use column 1. Anything you want to use. So the determinant of the matrix M is equal to, M is 3 minus 1, 5. So it's just 3 times the determinant of this portion right here. 3 minus 2, 5, 4. 3 minus 2, 5, 4. Now, I'm going to be using the first column. And so then now, secondly, it's going to be plus 2 times minus 1, 5, 5, 4. So it is minus 2 times
minus 1, 5.
minus 1, 5, 5, 4. Minus 1, 5,
5,
5, 4. And then we're adding 0. Then plus 0. So that would be the determinant of M, which is just 12 minus minus 10. That's positive 10. So that's 22. 22 times 3 is 66. Then we have minus 2 times, this works out to be 1. Minus 25 is minus 29. Minus 29 times 2 is 58. 58 plus 66 is 124. Easy, easy, easy stuff. Soft, 124. Soft with a capital T. And that's D. Easy. We're almost there. Finish strong. Always finish strong. Coming close to the exam, you start to feel a little bit tired, but we finish strong. We finish strong around here. So this question asks now, 2 coins and a die with faces numbers 1 to 6 are thrown together. Assuming that the die and the coins are fair, what's the probability of getting a head on 2 of the coins and a number that is less than 6? So first and foremost, the probability of getting a head on the first coin is, when you flip a coin, is only 2 output, head or tail. So the probability of head is a half. The probability of getting a head on the second coin is also a half. And then finally, the probability of getting a number that is going to be less than 4 is, I can get either 1, 2, or 3. So I can get 3 numbers out of the 6 of them. So that's the probability of getting a number that is less than 4. And so the probability of me getting all of them now, meaning the probability of getting head, head, and a number less than 4 is equal to, use multiplicative rule. So it's just now a half times a half times 3/6. Because they're independent events. That's why we use multiplicative rule. And so that probability is equal to 1/8. Because 3/6 is really a half. So the probability of getting a head, and a number that is less than 4 is 1/8. That's understood? That's clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. Nice. That's 1/8. All right, question 41. Question 41 says that if one marble is chosen without replacement from a bag of 11 blue and 9 red, then the probability of getting a red marble followed by 2 blue marbles is, so first and foremost is we need to get a red first. We have 20 in the bag. So the probability of getting red is 9/20. That's the first thing. Multiplied by, after we take out a red marble, then we have 19 in the bag. And so then now we're timesing it by 11/19. So that has to be D. That's the only option that have 9/20 times 11/19. So without even going further, we don't need to check anything more. That's D. Easy question. Question 42. Couldn't have been any easier. They're asking you just for the integrating factor. The integrating factor in this case is just e to the integral of 2/x. So that's all we're integrating. The integrating factor. The integrating factor is e to the integral of 2/x. To integrate 2/x is just ln x. So it just becomes e to the 2 ln x. We can bring up the power 2 to get e to the ln x squared. And then e cancel ln.
That's the thing.
That's the integrating factor. Imagine that's all the question asks you for, the integrating factor. They don't want nothing else but the integrating factor. Easy, soft. All right. Question 43. Question 43, it asks us to find the probabilities associated with K and L in the sample space. So they said the probability that L occurs given that K occur. So L occur given that K occurred. The probability L occur given that K happened already. So that's just equal to the probability of L intersect K over the probability of K. So that's all we need. The probability of L intersect K over the probability of K. So using the diagram now, the probability of L intersect K is in here, which is 0.15. So that's all we need to write for the probability of L intersect K, 0.15. Now the probability of K occurring sorry about that. The probability of K occurring is right here. All of this is K. This entire circle is K. So the probability of K occurring is 0.6. So it is 0.15 over 0.6, which is a quarter. That's the probability of L given K. Easy, soft. All right. Question 44 is another diagram question. They're asking now, what is the probability? What's the probability that the person is a female and drinks B? So using this, find what is the probability the person is a female and drink B. So in order to just look at it and know the answer, all right. Oh, so Kyra, yes, we've went through the previous papers. What I want you to do is send me your email in the chat so I can send you a recording of those lessons as well as the solutions. So just send me an email in the chat. All right. So back to this question is we're going to look at the table and they want to find the probability that the person is a female and drink B. So you look at female column and you look at B. So this is female and this is drinking B. Now they intersect at this right here. This is the number that they intersect at, 10. And so the probability that they is a female and drink B is 10 over the total 60. 10 over 60 is 1 over 6. That's the answer. That's using the table. So using the table, that's what you would do. All right? That's what you would do. All right. All right. So I'll send you all of the papers to your email. Thank you for the email. All right. So now, right here, this question, I just want to show you this alternate method. You could just use the table and say 10 out of 60. But let's say, just to use, for example, let's say Asani, Janelle, Ashley, Shaheen, and Rajay. Let's say all of you tied and got 45 out of 45, right? And they want to distinguish who is going to be the top student for the country. Since everybody tied and got this right, they're looking at the rough work now to see how you work it out. If you use the table, that's not separating you as, that's not separating the big dogs from the little dogs. So in order to get separated now, this is the method you can do now. The probability of female and drink B is, this is it. So I'm going to let F stand for the probability being female. Intersect drinking B, I'm going to call it DB for drink B. So that's what you want to find. Now that's just going to be equal to the probability of F given you drink B times the probability that the person drink B. That's using conditional probability, because we could change around this formula in order to make this part be the subject. Now the probability of being a female, given that you drink B, is, again, you'd have to use the table. And so given that you drink B, what's the chance of you being a female? So given that you drink B, that's 30. Chance of you being a female is 10. So that's 10 over 30. So you get 10 over 30 times the probability that you drink B now is 30 over 60. Probability that you drink B is 30 over 60. And this works out to be 1 over 6. If you do it using conditional probability method, I guarantee that if everyone ties, then this student would have been deemed the top dog. So that's how you, that's another way of doing it. Instead of just looking from the table and say 10 over 60. All right, so that's question 44. Final question now. So the final question is asking us for